All right, guys, here we go with 10.2 triangles. First thing, right out the box, you need to remember that all the angles in a triangle have to add up to be 180 degrees. So that means the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Sometimes it won't be as noticeable because the triangle won't just be sitting by itself. We could possibly, because we've already talked about parallel lines cut by a transversal, we could see something like this. And then we have to look hard and find that triangle inside of there. And then add the tool of the sum of the angles is 180 to all the tools we have for all the angles that appear when we have two parallel lines cut by a transversal. So remember, the triangle can look like anything, any shape of a triangle. If it's a triangle, all three angles have to be 180 degrees. All right, so let me set the scene for this. So we have line M parallel to line N, and they're cut by two transversals. And then hopefully you notice right away that we have a triangle inside of there, and then the two given angles are this one is 73 degrees and this guy being 110 degrees. Now we can go through here and find all the other angles that we have. So let's look at this and let's figure out where we want to start. I'm going to start definitely right here, and right here are vertical angles. So that means it has to also be 73 degrees. And then I'm going to continue to look around and I see, okay, I have this 110, but what I know from here to here has to be 180. So in my mind, I'm thinking 180 minus that 110 gives me 70 degrees. So the angle in there has to be 70 degrees. Vertical angle to that guy is right here, so it's 70 degrees also. All right, so I'm going to continue to look. Another vertical angle would be to my 110. These guys in here are both 110 degrees. I'm going to dig deeper into my toolbox and remember that alternate interior angles are congruent. So if this guy right here is 73, the alternate interior guy is also 73. Now I have two angles of my triangle. So I should be thinking, well, 180 degrees is my total, but I know 73 degrees and I know 70 degrees. And that's going to help me find that missing angle. So I have 180 minus 143 gives me 37 degrees. So then that third angle of my triangle is 37 degrees. Continuing with my thought process of vertical angles, I know this top one up here is also 37 degrees. And I'm going to go ahead and match up this vertical angle down here to be 73 degrees. And I almost have them all. Remember, from here to here has to be 180. So I'm thinking 180 minus 73. And we would get good old 107. So if that's 107, that's 107 vertical angles. And then I know from here all the way over here has to be 180, but I already have two of them. Three angles are making that 180 degrees. So in my head, I'm thinking 180 minus 73 plus 37. So 180 minus 73 plus 37 is 110. So then I subtract those and I get 70 degrees is left for right there, which puts 70 degrees out there. And I think I have captured all of the angles. Now, you may have thought about it a different way. There's no right or wrong way as long as you're using the tools that we have in our toolbox and walking yourself around all of those angles. All right, so let's find when they tell us we have triangle ABC, or they may tell us we have a triangle ABC that looks like this. And I just want us to remember and practice some of the stuff that we know. So in this first triangle, I know that the measure of angle B is 120 and the measure of angle C is 17, and they want me to find X. So two ways we can set it up. One with an equation. So I could say X plus 120 plus 17 equals 180. Or I can just do some math and say, okay, 180 minus the two known guys would give me my X right there. You're doing the same process, just two ways to look at it. So if I have 180 minus 137, we'd get a grand total of 43 degrees. Now, what I want to highlight on this second triangle, this box right here means that's 90 degrees. So anytime you see a triangle with a box right there, that means 90 degrees. And we're going to allude to that later on when we talk about Pythagorean Theorem and we're talking about side lengths. Right now, we're talking about angles. So we know that that box means 90 degrees inside of there. And then we also know that this other angle is 36 degrees. So again, they want me to find X. Same process. So I could say X plus 90 plus 36 is 180. Or I could say, hey, that total sum of 180 minus my two knowns would give me X. So I did it the math way last time. So right here, I'll do some equation work. And we'll have X plus 126 equals 180. I'm going to subtract 126 from both sides to isolate my variable, and I get that X is 54 degrees. So here, the measure of angle A is 54 degrees. Up here, just for notation, the measure of angle A was 43 degrees. All right, let me take it up a notch for y'all. I'm going to set the scene. All right, so there's our scene. First thing I'm going to do to attack this, because we want to find the measure of angles 1 through 5, I'm going to remember that, hey, that's 90 degrees right off the bat. And I'm going to mark that angle 2 and angle 3 have to be congruent because they're vertical angles. So first one I'm going to tackle is I know from here over to here has to be 180 because they're making a line. So in my head, I'm thinking 180 minus my known. So the measure of angle 1 is 90 degrees. Because those two angles form a line, and we already had 90 degrees. And then I'm going to say, wait a minute, I noticed something here. Here's a triangle. So I know the measure of angle 1 plus the measure of angle 2 plus 43 has to be 180 degrees. Well, we just found that measure of angle 1 is 90 degrees. I'm going to I'll just leave this measure of angle 2, and we'll keep working through this with the equation. So I combine my like terms, and I get 133 plus the measure of angle 2 is equal to 180 degrees. If I subtract that 133 from both sides, then I get 47 degrees. So the measure of angle 2 is 47 degrees. So if I know the measure of angle 2 is 47, we already said, then that would mean 3 is 47. So again, I have another triangle where I know the measure of angle 3 plus 60 plus the measure of angle 4 has to be 180 degrees. Well, I know that you just found the measure of angle 3 is 47 degrees. So here I am solving another equation. 60 and 47 gives me 107. I'm going to subtract that 107 from both sides. And the measure of angle 4 is going to be 73 degrees. Oh, I forgot to put 3 on here. All right, so last one. Remember, from here to here, they form a line, so it has to be 180. So 180 minus my 73 gives me a grand total of 107. So the measure of angle 5 is 107 degrees. All right, we're moving on, talking about characteristics of triangles. Several ways you can classify triangles. The first way is going to be by angles. So we can have an acute triangle, which means all angles are acute. Well, what does that mean? Acute means less than 90 degrees. Or we can say we have a right triangle, which means that we have one angle that measures 90 degrees. Or we can have an obtuse triangle, where one angle measures greater than 90 degrees. So, acute triangle, something like that. A right triangle, something like that. And an obtuse triangle, something like that. Okay, so that's by angles. Well, let's talk about, what about if we're talking about side lengths? So we have an isosceles triangle, what means that you have two sides that are congruent. At the same time, I want you to take note that that also means those opposite angles are congruent. So an isosceles triangles have two sides of equal length. All right, so an equilateral triangle. All sides have to be congruent, which automatically means that all of the angles are going to have to be 60 degrees because opposite sides of same congruent angles are the same. So all sides are congruent, have equal length. And then last but not least is a scalene triangle, which means no sides have equal length. No sides are equal. Okay, so I just want to make note of this isosceles triangle. Isosceles means two sides are congruent. So if I told you this was 4 inches, the congruent side is also 4 inches. What I want you to take note of is that means that this angle and this angle have to have the same measure. Okay? So if I wanted to draw a picture and we have some lines intersecting that look like this, and I tell you that this and this are the same, you can see our isosceles triangle pops out in there. And then I tell you that this outside angle is 120 degrees. So now you're digging into your tools that you know. If that's 120, all the way around to form a line has to be 180. So 180 minus 120 gives me my 60 degrees. So inside of here would be 60 degrees. If that's 60 degrees, we already just said that that also has to be 60 degrees. And then we would say 180 minus 60 plus 60 equals our missing top angle. So 180 minus 120 equals 60. So I've gotten even farther. I've found out that this is an equilateral triangle because all angles are 60. But that doesn't mean it always is going to happen like that. Let's pretend that I told you, go back to my first drawing, that this was 70 degrees in here. You would automatically say that this is 70 degrees. So then you would have 180 minus 70 plus 70, which would be 180 minus 140 would give you a grand total of 40. That's what would be left for that missing angle up there. All right. Let's keep trucking along. So we've been talking about congruency and some of the angle measures with transversals, but now we want to focus on similar triangles. So the big note that I have here is that similar triangles, the lengths of corresponding sides are proportional. Okay, not congruent, they're proportional, meaning we can write them into a ratio. So if I have one triangle, and you have to be careful how you look at this to determine, you have to really look at the markings that they give you. So I have one angle up here with 2 markings, 1, and this guy will be 3. And then we're going to set this one up the same way. Don't let them trick you if they set it up a different way. Look at the markings. So I know that this is 6 inches, 8 inches, and 4 inches. On the smaller one, I've got 3 inches, 4 inches, and 2 inches. And some of the questions are going to ask you, hey, are these two triangles similar? So to figure that out, we're going to, the easiest way is I'm going to write 3 ratios here. I'm just going to take the bigger one on top of the smaller one, and I'm going to list them least to greatest. So I have 4, 6, 8 for the big guy, and then for the small guy, I have 2, 3, and 4. Now, when I reduce these, I want them all to come out to be the same. That would tell me that these two triangles are similar. So 4 over 2 reduces to 2 over 1. 6 over 3 is also 2 over 1. And 8 over 4 is also 2 over 1. That's what I want to happen to say that these two triangles are similar. So I would name it triangle ABC is similar to triangle. I have to be careful. I have to match it up. ABC. So I would have to say DEF. And we're saying they are similar, which means corresponding side lengths are proportional. Okay, so we're going to do this, and we're going to use that tool. And I have 2 triangles, and you're going to be asked to explain why they are similar, or how do you know they're similar, and then find missing links. So the markings we've got are these markings right here, same, set up in the same way. So I've got some numbers here. And I'm already telling you, or we're going to check to see that they're similar. So first thing I want to do is look at these to see if we get the same ratio. So I'm going to match 30 matches to 10 and 39 matches to 13. So those are the 2 I know. I don't know 24 and X because we don't know what X is. So I'm going to say 30 over 10, that equals 3 over 1. And then I'm going to check 39 over 13 is also 3 over 1. So I'm going to say yes, they're similar because they have a corresponding ratio of 3 to 1. So with that being said, we can set up this proportion. 30 over 10 is equal to 24 over x. So here, be careful. If you notice, I have the big over the small. That's how I've set it up. 30 over 10, 24 over x. And then I can set my equation from here, solving proportion. So I would say 30 times x is equal to 10 times 24. So 30x is equal to 240. I divide both sides by 30 to isolate the variable, and I get 8, and this was in inches. So x equals 8 inches. Now remember, you can do that. You can set this proportion because we've said they are similar. If they were not similar, we could not set that proportion up. Okay, so I said I did it big to small. We could have done, there's another proportion we could have set up in here. We could have said 30 to 10 is equal to 24 to x. Oh, that's the one I did. Huh. Let's do 30 to 24 is equal to 10 to x. So I could have done it that way, where this is now both coming from the big and these are both coming from the small. And we would have the same equation. 30x is equal to 24 times 10. So forth, so on. So several ways you can do it as long as you get your corresponding ratios set equal to each other. All right, let's try it again, but with a different looking picture. Our picture now is going to look like this. So same thing, we want to show the triangles are similar and then find the missing length. So some of us may get it tricked. We don't want to get tricked because think of your toolbox. These guys are vertical angles. So those are already equal to each other. So I'm going to mark them with 2 tick marks. If I already know 2 angles are equal, then by default, these angles have to also be equal because I would be doing the math of 180 minus whatever the other 2 are. And we already know we had 2 of the same. So I'm going to rearrange these triangles because that's what helps my brain work through this, is if I rearrange them to a way I can see them in the same, I guess, setup. So I'm going to just set this one up like this. I'm going to make sure I'm careful and put the numbers in the right spot. And then I'm going to set my bigger triangle up in the same way. I'm going to go ahead and draw my angle measures on here. So I want them sitting the same way, but I'm going to make sure I have the correct sides length. So opposite of the 2 length is the x. Opposite of the one with 1 tick mark is the 8. And then this guy is just the one that we don't know, period. So I'm going to check out my ratio here. I'm going to set it up. So I have 7 over x is going to be equal to 5 over 8. And then we're going to set up our equation. So 5x is equal to 56. Divide by 5 on both sides. And we get x is 11.2 inches. So don't let them trick you on how they arrange your triangles. Just break them out, redraw them if you have to, so that you can see the setup and get the places and get your corresponding sides. This is one of the fun problems. So let me see if I can get my text to show correctly. There we go. All right. This is one of the fun problems. So let me draw a picture here. It says a man who is 6 feet tall. So here's my man. He's 6 feet tall. Is standing 10 feet from the base of a lamppost. Like my lamppost. So 10 feet from the base of the lamppost. And then his shadow is 4 feet long. And we want to know how tall is the lamppost. So you're thinking, well, I don't know how to figure this out. Well, similar triangles allows us to do this. So I've got one triangle here that looks like this. 6 and 4. And then I have the bigger triangle with the lamppost. And this is where a lot of mistakes happen, is that we see that this is X, but then we want to write 10 down here. But that doesn't give me that full distance inside of there. I've got to do 10 plus 4 and find out, hey, that's 14 feet. But now I have my two similar triangles, so I can come back in here and set up my ratio. So I could say X to 6 is equal to 14 to 4. Then I set my equation up. 4x is equal to 6 times 14. 4x is equal to 84. Divide by 4, and we get x is equal to 21 feet. So the lamppost is 21 feet tall. Okay, don't get stumped up by that. So always draw your triangles out. That's normally what helps out. All right, Pythagorean Theorem. This is what I ask people, what do they remember about math most? And they always tell me a squared plus b squared equals c squared. Well, let's put that into what it really means. That's Pythagorean Theorem. That only works for right triangles. So we've got, in a right triangle, you have the hypotenuse, always opposite the 90 degree, and then you have two legs. Okay, so what that means, if we're matching it up to the equation, the length of a leg is what we call A, the length of the other leg is B, and the length of the hypotenuse is C. So we're saying the length of leg A squared plus the length of leg B squared is going to be equal to the length of the hypotenuse squared. So if I have my right triangle and they tell me that this side is 9 feet, this side is 12 feet, and they ask me to find x. The first thing I really suggest doing every time you have a right triangle is go in there and circle that hypotenuse, because that's going to be your C, so that you don't forget how to set the equation up. So we set the equation up. Remember, a squared plus b squared equals c squared. Well, I just circled c, so that has to be out there. And then I would have 9 squared plus 12 squared equals x squared. Do some math, use your calculators. You get 225 equals x squared. Well, that is not x, so you have to remember to go back in and take the square root of that. So we're thinking of what number multiplied by itself gives us 225, and hopefully you're using your calculators, and you would find out that x is 15. So then that side, the hypotenuse is 15 feet. Okay? All right, word problems. We're talking about a slow pitch diamond. We got this. Here's home base, first, second, third. It's a square. They tell me that each of these are 62 feet. I want to know how far it is to go that way. So we have 62 feet squared plus 62 feet squared is equal to c squared, because that's my hypotenuse right there inside of this right triangle. And you do all of that math, you would find out you're looking for the square root of 7,688, and you get approximately, when you push the buttons on your calculator, 87.68 feet that the catcher has to throw the ball from home to first. All right, guys, stay safe. See you on the flip side.